Ever pondered the intricacies of machine learning? How do these intricate algorithms learn to predict, decide, and make sense of the vast seas of data? Well, it all boils down to two major learning paradigms: supervised learning and unsupervised learning. But what are their differences? Let's embark on a journey to understand these concepts and their unique characteristics. Picture this: you're a teacher in a classroom. In supervised learning, you're dealing with students who have textbooks with all the answers. You know the answers, they know the answers, and together, you work to understand the formulas, facts, and figures that lead to these answers. This is the essence of supervised learning. It's a learning paradigm where the model is trained on a labeled data set. Each training example is paired with an output label, and through this process, the model learns to predict outcomes for unseen data. Now imagine a scenario where your students have no textbooks, no answers. They're given a problem and they need to figure out the solution on their own. This is akin to unsupervised learning. Here, the model learns from data with no labels, no clear answers. It's like a detective, piecing together patterns, structures, and relationships in the data to make sense of it all. So what sets these two learning paradigms apart? Well, it's mainly about data labeling, objectives, and resources. Supervised learning needs a data set with known labels for the output variable, while unsupervised learning can work with unlabeled data. The objective of supervised learning is to predict an output based on input variables, whereas unsupervised learning seeks to understand the structure or distribution of data. And while labeling data for supervised learning can be resource-intensive, it offers a clear metric for model performance. Unsupervised learning, on the other hand, doesn't need labeled data, making it useful when the labels are unknown or hard to obtain. There's also a third player in the mix, a hybrid model called semi-supervised learning. This approach uses both labeled and unlabeled data, combining the best of both worlds. So, to recap, supervised learning is like a classroom with a teacher guiding students using a textbook with all the answers. Unsupervised learning is a detective story, where the model must figure out the patterns and structures in the data on its own. And semi-supervised learning is a blend of these two approaches, using both labeled and unlabeled data. Understanding these learning paradigms gives us a glimpse into how machine learning and AI make sense of our complex world. Whether it's predicting outcomes or uncovering hidden patterns, these learning paradigms form the backbone of our modern AI systems. So the next time you marvel at a smart recommendation or a precise prediction, remember the learning paradigms that made it possible.